Continuing in our study of circles, today we're going to talk about inscribed angles and polygons. These are angles and polygons inscribed inside of a circle. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. So remember, we talked about a central angle earlier. Now we're going to talk about an inscribed angle. The arc that lies in the interior of an inscribed angle and has endpoints on the angle is called the intercepted arc. So in this case, I have the inscribed angle and its corresponding intercepted arc. The measure of an inscribed angle is always half the measure of its intercepted arc. So when I'm looking at the measure of the angle, it's half the arc, or the arc is twice the angle, whichever way you look at it. So find the indicated measure in circle P. I want angle T. Since the angle itself is half of the inscribed arc, angle T will be half of 48, which is 24 degrees. Looking for the measure of arc QR, the measure of arc QR. Well, what I'm going to have to think about here is the fact that RT is a diameter and QRT excuse me, is 50 degrees, so that's going to make QT 100, and so that for measure of QR, that's going to leave 80. So TQ is 2 times the measure of R, which is 100. Since TQR is a semicircle, then measure of QR is 180 minus the measure of TQ, which means that it is 80 degrees. Find the measure of TU, arc TU, and the measure of angle TSU. Well, arc TU is related to angle R, is the intercepted arc, and angle TSU also has an intercepted arc of TU. Now we know from theorem 10.7 that angle TRU is half of TU, so we know that TU is 68 degrees. And then we also know that TSU is half of 68 degrees, and half of 68 degrees is 34 degrees. So we can see that both of those angles have a measure of 34 degrees because they're congruent to one another. If 2 inscribed angles of a circle intercept the same arc, then the angles have to be congruent. We just showed that in the last problem. So name 2 pairs of congruent angles. Well, let's look at these angles. I know that this angle JKML and angle KJL both have KL as the intercepted arc, so they would be congruent. And angle JKM and angle JLM both have the intercepted arc of JM, so they would be congruent. So we know that this angle is equal to this one, and this angle is equal to that one, so we just need to find that inside of here. So JKM is congruent to KJL. That's not true. This one is not congruent to that one, so we can rule out A. For B, JLM is congruent to KJL. No, that's not true either. JKM is congruent to JLM. JKM and JLM, that is these angles right here, and yes, they are congruent. So let's check our other pair. KJL and KML. That would be this angle here and this one here, and they are congruent, so C is my answer. So what we do is we find the ones that have the same intercepted arc. Find the measure of the red arc or the angle. So in this case, I'm looking for the angle. Remember that the angle is half of the arc, so that would be a 45-degree angle. In this one, I'm looking at the arc. If the angle is half of the arc, that means the arc is twice the angle, so 76 degrees. And if I'm looking for the red angle, which is ZXN, or W, I believe is what that is supposed to be, it didn't take, then ZW intercepts the arc of 72, so that makes it twice as much, 144, and then that puts this one back to be half of that, which is 72. Remember, if they're congruent, then they have to both be the same. An inscribed polygon is a polygon whose vertices all lie on a circle. The circle that contains the inscribed polygon is called the circumscribed circle. Remember, inscribed means inside, circumscribed means it goes around it. So I have an inscribed triangle or an inscribed quadrilateral. These circles are circumscribed about them. Theorem 10.9 says that if a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. And conversely, if one side of an inscribed triangle is a diameter, then the triangle is a right triangle, and the angle opposite the diameter is the right angle. So in this case, what I see is that this angle would be a right angle because the diameter would be the hypotenuse. If you have a right triangle inscribed in a circle with a radius of 10 inches, if one chord that forms the leg of the triangle is 12 inches long, what's the length of the chord which forms the other leg? Well, here is my triangle, radius of 10 inches. Here is my inscribed triangle. What I have is the diameter would be 20 because it's twice the radius. One of my legs is 12. Excuse me. The other leg is what we're looking for. So we can use our Pythagorean theorem and solve for x, and we'll see that x is 16 inches in this case. If a quadrilateral can be inscribed, then its opposite angles are supplementary. So what that means is that angle D and angle F have to add up to be 180, angle E and angle G have to add up to be 180. And this is just for a quadrilateral. So any quadrilateral that is inscribed is going to have opposite angles supplementary. So we're going to find these angles. Well, I know that to find x, I've got to have 80 plus x is 180, so x would be 100. If I'm looking for y, then I know that 75 plus y is 180, so y would be 105. For b, I know that these two are equal to each other. Notice I got 2a and 2a. I've got opposite angles. This looks like a kite, but let's see how this works. 2a plus 2a is 180, that's 4a, so a is 45 degrees. In this case, 4b plus 2b is 180, 6b is 180, so b would be 30 degrees. So here's one for you to try. We get y is equal to 112, and we get that x is equal to 98. Now, how did we get that? We had y plus 68 was 180, and we had x plus 82 was 180, and we simply solved those. In this one, I have, looking for c, I'm going to say that c plus 2c minus 6 equals 180. and solve that equation. Excuse me. And for x, I've got 10x plus 8x is equal to 180. Solve that equation for x equals 10.